I will begin with something that's perhaps a bit playful and, I don't know, interesting. So all of you have done a lot of work with interactions with robots or virtual humans, and so these human-computer interactions and robotic interactions. What was the most surprising and perhaps funny outcome, unexpected, that has occurred during testing and development with your robots or virtual humans? Maybe starting with you, CU.
Let me think. So one thing is like when we try to synthesize virtual. Is it working now? Mm-hmm. Yeah. Okay. So one thing is when we try to synthesize virtual humans. So sometimes we think like the model is not performing so well, but the synthesized behavior looks interesting. So in the sense, we can kind of tell a story out of some like unexpected behaviors. So that's really the fun part. Like we were hoping the model performing that way, but the model is really performing a different way. But because we are really synthesizing virtual humans, as human ourselves, we see that, and then we can interpret it. We see the output differently.
So I was somehow expecting like the human fell through the floor, or like...
Yeah, there are also like that part. I didn't show like when we train the RL algorithms for driving the virtual humans. Actually, in the first few hours of training, the virtual human just fall on the floor like with weird pose. That was also a fun part for me.
Okay. Because I think that could be quite interesting to see these unexpected movements that your virtual humans are doing that we don't naturally create. So perhaps that's also in the robotic space. So yeah, maybe Kendra?
Yeah, for sure. I think watching robots as they're learning is pretty humbling. Like there's things that we take for granted as being really, really easy. That's super, super hard. Like we have these great hands that are like very dexterous. We know, if you're going to open a drawer, usually reach forward, and you'll see as these robots are learning kind of like how to do these really basic motions, things like reaching and contorting themselves kind of behind, their backs, and, falling. We work with quadrupeds also in our lab, four-legged robots, and sort of seeing them try to learn how to get back up after they've fallen over. It's a little bit like watching a like really, really young child sort of like explore around their playroom and kind of like, try to feed themselves, but they're kind of like reaching over here. And so I think, so it's humbling to watch.
I think the moments I like the most is when we do a lot of exhibitions with interactive pieces. So like the last one I showed. And what I really love to observe is how visitors start to try out how to engage with the machine. So we don't never explain them how it works. We give them the thing, and then we say, you figure it out, because I wanted to know if they would start to learn a language with the machine, how long does it take, is it really as intuitive, etc. And these are really the most funniest moments when people tell me it's so funny how humans really then try to interact. They read also things wrong, of course, and then interpret them wrong, which is very interesting, tells a lot about the human nature. When and it shows how much we want to engage. We want that the machine reacts to us, and we overread it. And I think it's a beautiful mixture of like the super excitement of people that start to see, okay, something like acknowledges my presence, and at the same time, how they completely also read things wrong, but they are fine with that. They start to develop a relationship with it, and I think that's very interesting. It's something it's hard to recreate in a lab. This is really where you have to go out and just let people test it.
These spontaneous interactions.
Yes.
Yeah, cool. So my next question is more focused on the theme of the symposium, and here it's on human-machine teams for design and sustainable construction. I'm going to touch upon the sustainable construction. So I would like to now ask these questions about how your work can be done to support design and sustainability. Perhaps I'll start with one very targeted question, and this was inspired with a discussion that I had with CU this morning, which she then asked how, and this could be directed towards you, Daniela, and Kendra, having a background in architecture, how do you see, so how could CU's work with virtual humans and avatars support the early design phase in architecture? And then the second part of that question is, how could this then be extended to support sustainability objectives?
I hope they are useful.
Yeah, I mean, I think when you're, I have to reach back in time, because when I went through architecture school, it was like 15 years ago. But one of the things that really stands out to me is when you sort of first get kind of the program of what the building should be designed to do. It's all about like, what are the kinds of things, what are the ways that a person is going to need to move throughout the building, use the building, experience the building. And so I think from kind of a human simulation perspective, being able to model and like see what might happen when you fill a space with lots of people and they all need to exit at one time. And you can start to, maybe also build on top of that things like how much heat is being generated by having a lot of people in one room, and start to, I think, get maybe deeper into some of these analyses about what it feels like to actually occupy a building before you even get into, kind of some of the finer details of the design.
Yeah, thank you. Daniela?
How it helps to build more sustainable. It's a difficult question, because of course you can say, yes, you can test the floor plans, but can you? Because it's a very complex thing. So I think it's awesome work, and it's a good start, but I think to actually use that to answer a question of sustainability, we need a lot more, so many parameters that we can say it's an awesome part, one puzzle piece that we can use, especially when we talk about digital design and virtual spaces, and to test them. And I do agree, I see the work not in the one family house or that, but especially like in big university buildings or hospitals or stuff like this, where you need a mass of people to actually simulate what could happen in, how would the stream of people would be. I think about airports. Just calculate, like how many airports do we know that are terribly built because they still manage to build the too long pathways between the gates. And just there I really think this helps a lot. If that helps to build more sustainable, I think it helps to build better. And it's a good thing to build better, and I think that's what we should really focus on. And one puzzle piece maybe to build more sustainable. I would love to see them walk in airports, especially the bad ones. I would love to see the rating of different airports.
I feel more motivated.
So this next question, perhaps I'll direct towards you, Siu, is within our discussion this morning, I also asked about this sustainability question, especially perhaps related to energy consumption. How much of a dialogue is this how much is this present within your community? This question of sustainability or even energy
consumption?
Yeah.
Yeah. So people, I think, are really thinking about it, especially nowadays we're talking about large-scale models. So training large-scale models needs lots of electricity. It's really like energy consumption, right? So I think it's definitely a very important topic. And also, I think for each individual researcher, we should really pay attention when we really design such models. And we have to, I mean, especially I think for big companies, like this is a really important questions. Yeah, but my point is like people are really discussing about that. And
yeah, you also mentioned something with respect to having virtual humans might actually change the way we the way we communicate, and perhaps have less in-person meetings.
Yes.
If you have this 3D virtual human sitting next to you, it would be like if Kendra was sitting here as a hologram, right? So it's perhaps it could change the way we commute, and therefore reducing certain carbon emissions. So this was,
Yeah.
I think it could go in that direction. The next question, which I see we have 5 minutes here, and I want to leave an opportunity for the audience to ask any questions, because I still have a few more. So, does anyone want to ask a question before Yep.
Thank you very much. Quick question, would it be possible to think actually of your work as input work for design instead of having the design first and then the work inside, in the sense of once you have, for example, humans that are capable of moving, you could actually use that as instructions for parametric design behind it. You could also add information such as how much oxygen you consume, how much heat you produce, what's the noise and different actions that a human is producing, to actually feed the design pipeline this way around. And the same also with the language modeling that we could use to actually inform the design process. So would that be possible to, or do you see the option to do a switch actually of paradigm?
Me?
The three of you.
Yeah. I mean, I have some. I'm not. So I mean, for us, like this human model, it's we can optimize it, right? So if we get some objective from the other side, right, like energy consumptions or like other parameters or other objectives, we can optimize it. And if the other side of the world, right, like the design process is also parametric models, and then I think it would be possible to also optimize that based on some output of our models. So I think it's very high level, but that's how I see this. Yeah.
Any other questions? Yes.
Yeah, thank you for the great talks. I really enjoyed them. I have a question regarding simulating humans and robots also on building sites, regarding simulating human and robot interactions beforehand, before a robot comes to a job site or a building site. And would it be beneficial, or do you think this is overthinking a problem which does not exist?
Yeah, I think, so one thing that we've learned in our research and in our work is today, at least, you can only get so far with simulation. It's really hard to reproduce and replicate all of the sort of like physical behaviors that you see or would experience. So I think there's certainly ways that you can like deploy and use simulation today that's really, really useful for either training algorithms to pre-visualize sort of like how something will actually come together on site. Another way that I've seen it used that's been, I think, pretty helpful, and this is going back to some of our work at Bot and Dolly, was trying to train the people that are going to be working around the machine what to expect and how to react before they actually get on site. And that's something that I found personally to be really helpful from kind of a sort of like safety perspective, in a training perspective.
So I will, unless there are any burning questions in the audience, we do have a burning question. Okay, please.
Well, thank you for this great closing panel. In fact, I think it's really nice to close with actually something that we initiated actually the symposium for. And when I recap basically also what we have seen yesterday in this kind of new developments in robotics, and seeing what you're doing now, I think it really, I tried to find the words, but we had this notion yesterday that we are still stuck in the modernist thinking of opening a CAD model, having a blank page, and starting from scratch, right? And what you showed, Daniela, quickly in your presentation is also the, let's say, the production schemes for building architecture is still like for building new, in the sense that you have you can pre-program everything. You have the very structured conditions in order to produce, or even in order to be able to produce. No? And I see that all of these new technological developments now enable these robots, machines, to be in the context of the physical world, no? And to interact with humans, of course, means that you need to have an understanding how humans will behave. You also want to predict it. You want to understand, and you want to give the machines the understanding of the physical world. No? And after the understanding comes the interaction, and I think this is where Kendra's work is just fantastic to see. No? Is this fluidity that suddenly appears with the language models that you use actually to use robots in a completely, entirely new way and interacting with people. No? So I think this was more like maybe already a wrap up, but maybe something that you can maybe in one sentence just share one more sort of view on that. Thank you.
I really liked how you put it, because I think it's a nice kind of, order of things with all systems that are not pre-programmed, that are all based on, we try to create systems that are open enough to react to complex things. Simulating human is complex. Communicating with a robot is complex. The construction site is complex. So I think it's interesting, because then it shows that the really big importance to create systems that can handle complexity, and thought processes and thought concepts that can handle complexity, and that we should give up this idea of that we have kind of full control and we can decide each step what's going to happen, but we actually need to build systems that are open enough that can handle complexity within themselves, instead of always needing us for the evaluation of decision making.
Great. Thank you. If I may ask one more question, this would just be wrapping up the panel, the final panel of the symposium, and perhaps even sharing with us, each of you, in a one sentence, what would be your takeaway from this symposium, and sort of looking into the future, what should we be working on within the future of construction for these ambitious objectives? So, some type of takeaway. I can, yeah.
Sure. I can start with something. So I think it's as someone I think earlier said, it's not a knowledge gap, it's a knowledge canyon, and I think that is true. And so I would sort of, pose the question of like, what should the systems architecture look like for the future construction site? And I think there's a few different parts of that. There is the fundamental science, which is a lot of what we're doing with kind of like, how do you build and train these models with these kind of like intelligent capabilities? But then how do you also, integrate them with machines, with all of the other apparatus and controls that go with it? And then how do you do that in a way where it's, it fits with the rest of the sort of design and construction workflow and process, which I think is a huge undertaking. And I don't think it's something that'll be solved by any one person or any one company. So.
Great, thank you. You also just had a very nice concluding statement. Well, so.
Maybe like one thought that didn't leave me since the starting of the symposium was, it's so much great work here. We all seem to agree on the importance of the matter, and we still don't have the solution how to reach a broader mass, how to actually get the recognition of the great research that we do, and the solutions we can provide. So I think one of the big question marks that I have is how to reach a broader audience with the answers that we have. And outside our bubble, that is great, but I think it's really time to think, okay, what do we have as architects in our hands to go more publicly with these things, to reach a broader mass of people, to actually start to show them also what we have in our minds, what the solutions we have, and possibilities that are there.
So for me, I see connections between our work and other people's work. So we are not just synthesizing virtual humans, we're also seeing humans, perceiving humans. I see perceiving humans potentially have applications, right, connections, and also synthesize virtual humans and human-robot collaborations. So I see lots of connections and potential collaborations. So that is exciting.
Great. So thank you all very much for your final words, your presentations, your very, I would say, thoughtful insights into your work and in the field. Thank you also for joining us for this panel. I guess I hand it over to Pierluigi, or, yeah, so thank you.